Welcome to Advanced Data Analysis 2 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll be continuing Chapter 7 about analysis of covariance. So we'll scroll on down from the website to the lecture notes, Chapter 7. So we'll look at generalizing the analysis of covariance model to allow unequal slopes, unequal intercepts, all the varieties of those combinations of whether the slopes are different, intercepts are different, and so on. So often in these types of ANCOVA models, we're interested in comparing whether regression lines are the same across groups, and if they're different, how those regression lines are different. So we'll look at an example where we've got three groups and we have a single regression effect. So here we've got the IQ example. We have IQ scores of identical twins. This is a very unusual data set because twins were born and one twin of the pair was raised in a foster home called IQF, and the other was raised by their natural parents, IQN. And we want to know what the relationship is between these sets of twins and whether their IQ scores differ. So we have 27 pairs of twins, which we're going to separate by social economic status. Okay, so we'll have a high status, a medium status, and a low status. And these are the status of the natural parents because that's the conditions under which the fetuses were developing. And a priori, that means before we observe the data, there's no reason to assume that these regression lines are going to be different or equal or anything. So we're going to start with the most flexible model possible in order to observe those differences if they exist. And the most general model has 6 parameters. Right? So think of, we've got 3 groups, high, medium, and low, and we are relating IQ scores between the natural and foster parents. And so if you were to fit a single regression line to each social status, right, that would be a slope and intercept, and you do that 3 times. So that's 3 slopes, 3 intercepts, that's 6 parameters. Okay, here are the original data set citation. All right, so we're going to create indicator variables, and there's different notation for this. What I showed in class is what I actually prefer, but this is a sort of a shorthand for this. We're going to let the low group be the baseline group. So it effectively, the intercept that we get for the entire regression model is going to be the intercept for the low group, and the first slope parameter is going to be the slope for the low group. Then we'll have modifiers for the medium and high group, and the modifiers are going to use this indicator variable notation. So I1 is going to be the indicator variable for whether we're a high status family or not. And so I1, if it's a low group, it equals 0. If it's a medium group, it equals 0. But if it's a high group, indicator 1 equals 1. Similarly, I2 is the indicator for the medium group. It's a 1 when we're a medium status group, otherwise 0. And that is going to give us, okay, so let's keep going. And here then is the full model. Maybe I can keep all that on the same screen. So we're going to predict the IQ of the foster child based on the IQ for the natural parent raised child. I may shorten some of my words about that, natural child, foster child. We know that it's the parents who are the natural parents and the foster parents. So here beta naught ends up being the intercept for the low group, and beta 3 the slope for the low group. And then we have these indicator variables, I1 for the high group and I2 for the medium group. And what ends up happening when you start solving these equations using I1 and I2 for each of the separate classes. So say we've got social status L, then that means both I1 and I2 equal 0. So when you plug that in this equation up here, I1 and I2, those both equal 0, so they go away. And we're left only with IQ Foster, okay, equals beta naught, plus a bunch of zeros, plus beta 3 IQN, plus here's IQ1, which is 0, and IQ2, which is 0. And so this is the regression model for the low status group. Beta naught plus beta 3 IQN. Beautiful. And then here's the medium group. Doing this in a weird order, I guess. So in that case, IQ2 equals 1, and IQ1 equals 0. So anything with an IQ1 is going to stick, I2 will stick around, and I1 will be 0. So as we go up here, IQF equals beta naught plus, we're in the medium group, so I1 is 0, I2 is 1, so we end up with beta 2, there we are, plus beta 3 IQN, beta 4 I1 is 0, so that goes away, I2 is 1, there's beta 5 IQN. And then you can group the terms, right? So both beta naught and beta 2 are just coefficients, we can add those together. And then beta 3 and beta 5 are both multiplied by IQN, so we simplify. And now we suddenly see the structure of the model. Beta naught is the intercept for the low group, and beta 2 is the offset of the medium group compared to the baseline low group. Similarly, beta 3 is the slope for the low group, and beta 5 is the difference in slope between the medium and the low group. And then similar for the status high group. Okay, when we've got beta 1, which equals, I1, which is the indicator for the high group, equals 1, and I2 equals 0. So in this case, we get the modifier beta 1 down here, and I1, we get the modifier beta 4 down here. Okay, so now beta 1 is the difference between the high group intercept and the low group intercept, and beta 4 here is the difference in slope for the high group relative to the low group. And that's what all that stuff says. So this allows a lot of flexibility. In fact, you can generate any set of regression lines from this full interaction model between the slope parameter or the continuous variable, the natural IQ, and the status groups on the prediction of the Foster twin IQ. Okay, so let's look at this in R. So we'll read the data set in from the website. Oops, don't click on that. Well, there's the data set. Anyway, we have 3 columns. We have the Foster IQ, which is the response. We have the natural IQ, which is the predictor variable. And we have the status categorical variable coded high, medium, and low. Okay. And we want to set, after we read this data set in, we want to set L as the baseline group to correspond to the example in the notes. So the function relevel, there's lots of ways to do this. This is probably the simplest. The status group, we're going to set L as the baseline level. And when we look at the structure of the twins data set, we see that we have integer variables for the Foster and natural IQs, but the status now, this by default would have been alphabetical, right? So if I know my alphabet, that would have been H, L, M. But because I've done the relevel, now L appears first. All right, let's plot this data. And what do you think? So we've got status L is red, that's the baseline group. We have high is green, medium is blue. And to my eye, this suggests remarkably parallel lines for an example like this. And in fact, they're the vertical spread, right, we don't have very many observations. The medium group, for example, looks like it has 6 observations. There's quite a bit of spread around that regression line, so I wouldn't be surprised if also the intercepts are the same. Now, one plotting detail here, we have IQ on both the horizontal and the vertical axis, and they basically have similar ranges. Look at how square this plot is. This is really critical, I think, in being honest in your plotting, that the axes, in terms of the, if this is basically roughly an inch, and this is an inch horizontal and vertical for 20 units in IQ, that aspect ratio be maintained so that it doesn't look like the slope is, less than a 45-degree angle. This angle basically looks like 45 degrees. So let me scroll up for a moment, and I'm going to zoom in on this code. I've actually done several things in here. The point that I'm talking about right now is coordinate axes are equal, and you can set the ratio between the x and y axes. And so ratio equals 1 is giving me that nice square set of axes. Furthermore, I've also calculated, let's find this variable, the dat range. Oh, it's right here. Okay, so here I'm asking, what is the range of both of these columns, the Foster and natural IQs? So that's the range function is going to give us the minimum and maximum values together. And so here I'm setting both the x limits and the y limits as being the minimum and maximum of both columns combined. And that means that these square axes, if I zoom back out, have the same range from 60 to almost 140. There's another thing here is I've used plotting symbols L, M, and H as the observations. So this is double coded for sure. I've got color and I have the letters, and I think we've seen this before. There's a package R.oo which allows us to look up the ASCII code for plotting symbols. So it's not just as easy, unfortunately, as saying what shape do I want to plot and then putting in the letters. You actually need to indicate a certain integer. And so this function, or this package rather, R.oo, allows us to convert a character, so the letters L, H, and M for low, high, and medium, to the appropriate integer, which are going to be the plotting values. Oops, oh boy, plotting values. So here I look at the status, and I look at what are the unique values from status, and that's H, L, and M. Then I sort these alphabetically, which may or may not be important, and then I convert those to those characters L, H, and M to integers, and those are the values that I can use then as my shapes to plot. Whew. Well, fortunately I figured that out, and you'll never have to figure it out, but you can just come back here and do it when you need that. All right, so that's what created that plot. Let's continue. So let's fit this full model. Let me page up for a moment and remind ourselves we're going to fit this full model, equation 7.1, where we have separate intercepts for each and separate slopes for each status group. I'll page back down below the plot, and this asterisk expands into the main effects for the slope, IQN, and for intercepts, the statuses, as well as the interactions of both, which are specified by a colon, which we'll see in a moment. So the first thing we're going to do is ask the question using the ANCOVA table whether there is an interaction or not. So here we've got the ANCOVA table. IQN just has 1 degree of freedom. Status, there's 3 statuses, so we have 2 degrees of freedom, asking whether there are differences from the baseline. So there's 2 differences from baseline, that's the 2 degrees of freedom. But the main one that we've got on the next page is whether there is an interaction. And this is 2 degrees of freedom also. These 2 degrees of freedoms are the differences in slope between the 3 between the medium and the high relative to the baseline low group. And look at this p-value. It's actually almost hard to get a p-value closer to 1 than that. So this suggests that, in fact, there is not a difference between the slopes of these 3 social groups. If we look at the summary for this model, so we've already conducted the important hypothesis test. Okay, I just want to provide a quick interpretation of the summary table, even though these tests don't come into play here. But here are the 6 coefficients. Okay, 7.2 is the intercept for the low group, and then we have, this is the slope for the low group. 0.9. It's close to 1, right? So that a 45-degree angle here would be a slope of 1. Then we have the difference in intercept for the high group and the difference in intercept for the medium group. That's basically beta 1 and beta 2 in the model above. This slope was beta 3. And then beta 4, the difference in slope for the high group, and beta 5, the difference in slope for the medium group. And these tests that are being performed are of whether each of these coefficients equals 0. Now this is not really a very interesting test for us, because this is testing only whether the slope for the medium group is different from the low group. There isn't the specific test here, for example. Well, let me do a couple more things. So this tests whether the medium slope is different from the low group. This tests whether the high group slope is different from the low group, but there's no test here for the difference between the medium and high group. And so, unfortunately, or this is just sort of the way it is, this summary table only compares to the baseline group. It is the ANCOVA table above that tests whether all 3 slopes are equal to each other or not. That is why we start with this test. This is effectively, right, just like in chapter 5 from last semester when we did an analysis of variance, we test the global hypothesis first of whether all the means are equal to each other, then we do all the pairwise comparisons. So here we're testing whether all slopes are equal to each other, and if they were different, then we would probably follow up and do pairwise comparisons of asking which pairs of slopes. But this summary table does not give us that. This gives us only comparisons to the baseline group. All right, let's continue. So let's plot some diagnostics to see whether this model seems to fit or not. We have residual plots versus fitted seems to have consistent spread for all 3 groups. And notice the L, M, and H's here for the plotting symbols. I've done as character the different status groups as the plotting character. We don't really have any influential points that are strongly influential relative to others. And the one that is most influential, well, 13 is mostly because of leverage, not a big deal. These variances don't look too different relative to the fact that we've got fairly small sample sizes. Relative to the IQN, this looks pretty good. Normality looks great. So it looks like our model fits pretty well. No real transformation suggested, and so on. So the natural way to express the fitted model is to give separate prediction equations for the 3 status groups. So we've got, for the predicted Foster-raised IQ, we have the intercept and whether we've maybe a status indicator for which group we're in, as well as multiplied by the natural group, we have the slope coefficient for the reference group, the baseline group, and then whether we've got a special coefficient. So let's look at our three groups here. We have our baseline group, the status equals L, and we've got the intercept and the slope. These are coming right off the table from above. And let's scroll up for a moment. So we've got 7.2 and 0.948. If I scroll up to the summary coefficient table, we have 7.2, which is the intercept, and 0.94, which is the slope for the baseline group. Now in a moment, let's just lock in our minds the offsets for the high group, -9 and 0.029 for the intercept and slope offsets. So I'll page back down, and let's just jump to that one. Here's the baseline low group intercept and the offset, -9. And combining those, we get -1.8. And then here is the slope for the low group and the slope for the high group, combining, and that gives us the slope for the high group. And same thing up here for the medium group. Okay. And so finally, we have these three regression lines. We've got, can I get them all? The low group regression line, the medium group regression line, and the high group regression line. And that was, if I page back up, that is actually what is plotted here. All right, I'll page back down. Great. So I'll come back in the next video and we'll look at model selection here and see how this most complicated full interaction model can simplify based on the hypothesis tests that we have done.